Yes, ma'am. I've shared it you on WhatsApp.
Yeah, I'll check, Aishwarya. So we stopped here in the last class. We understood this one. So continuing with NCRT. Example 5. The internal measures of a cuboidal room are 12 meters by 8 meters by 4 meters. So length, breadth, and height. These are the dimensions of a cuboidal room. Find the total cost of whitewashing all the 4 walls of the room. Cost of whitewashing the 4 walls, not the ceiling. See, in a room, the 4 walls and the ceiling can be whitewashed. The floor is tiled. The floor is tiled. Okay, tiles are laid on the floor. The 4 walls and the ceiling can be whitewashed. But here only the walls are whitewashed. See, the question is find the total cost of whitewashing all the 4 walls of the room. If the cost of whitewashing is rupees 5 per meter square, what will be the cost of whitewashing if the ceiling of the room is also whitewashed? So you need to find the cost of whitewashing the 4 walls and also the cost of whitewashing the 4 walls, including the ceiling. So somebody tell me the formula to find the area of the 4 walls, which is nothing but the curved surface area of a cuboid. CSA of a cuboid, which is the area of 4 walls of a room, is given by, what's the formula?
2HL plus B square units.
Very good. 2H into L plus B square units. 2H into L plus B. Curved surface area or area of 4 walls. Area of 4 walls is given by 2H into L plus B. So find the area and multiply the area by 5. Because the cost of whitewashing 1 meter square is 5 rupees. So whatever is the CSA into 5 will be the total cost of whitewashing the 4 walls. After that, find the area of the ceiling also. The area of the ceiling is given by L into B. Area of the ceiling is L into B. So to this area of 4 walls, 2H into L plus B, also add the area of the ceiling to get the total area of the 4 walls and the ceiling. To the area of 4 walls, 2H into L plus B, also add the area of the ceiling, L into B. So this will give you the total area of the 4 walls and the ceiling. This answer into 5 will be the cost of whitewashing the 4 walls and the ceiling. So you can see here, area of 4 walls, 2H into L plus B. Substitute the values carefully. H, see this is L, this is B, this is H. So 2H into L plus B, 2 into 4. 2H, this is H. 2H into L plus B. So this is the area of 4 walls. So the cost of whitewashing the 4 walls will be whatever is the area, 160 into 5. Because 1 meter square, the cost is 5 rupees. So for 160 meters square, it will be 160 into 5. The rate is given here, 1 meter square, 5 rupees. So for 160 meters square, it will be 160 into 5, which is 800 rupees. Now let's find the area of the ceiling, L into B, 96 meters square. Now, so here I've done it a different way, but then again, I think you should be able to understand. So the cost of whitewashing the ceiling alone I've found. The cost of whitewashing the ceiling alone will be 96 into 5, the same rate, 5 rupees per meter square. This is the area of the ceiling. So the area of the ceiling into the rate, 5 rupees. So this is the total cost. Or this is the cost of whitewashing the ceiling alone. The ceiling alone. So now the total cost of whitewashing the 4 walls and the ceiling will be 800 plus 480. 1280. We have to answer two different questions. The cost of whitewashing the 4 walls is this one. The cost of whitewashing the 4 walls, including the ceiling, is this. So that's about example 5. Here, in a building, there are 24 cylindrical pillars. Now you can see that the pillars, the circular faces of the pillars are not visible. A cylinder has 2 circular faces. A cylinder has 2 circular faces. The circular faces of the cylinder, they are not visible because the top circle is stuck to the ceiling and the bottom circle is stuck to the floor. So what is visible or what you can feel or what can be painted is only the curved surface area of the cylinder. Even if you wish to paint the circles, they are stuck to the ceiling and the floor. So they are not, that surface is not available or visible to be painted. You can see the figure is given. The question is supported by a diagram. So you can see from the diagram that the circular faces of the cylinder, the top circle and the bottom circle, they are stuck to the ceiling and the floor respectively. So the area available to be painted is the curved surface area of the cylinder, which is given by the formula 2 pi RH. Which is given by the formula 2 pi RH. This is the formula to find the curved surface area. This one, the curved surface area of a cylinder. All right. So in a building, there are 24 cylindrical pillars. The radius of each pillar is 28 centimeters and the height is 4 meters. Height 4 meters. Radius 28 centimeters. Find the total cost of painting the CSA of all the pillars at the rate of rupees 8 per meter square. Even if this word curved was not used, you should find only the curved surface area. Supposing the question was find the total cost of painting the surface area of all the pillars. Supposing the word curved was missing. Even if that word was not given or mentioned, it still means only the curved surface area. So find the total cost of painting the CSA of all the pillars at the rate of rupees 8 per meter square. So you can see here that the rate is given per meter square. So it's convenient to have the height and the radius in meter so that you will find the area in meter square and you can multiply that area with 8 to get the total cost straight away. The rate is given per meter square. 1 meter square, 8 rupees. So you find the CSA of all the 24 pillars in meter square. To find the curved surface area of all the 24 pillars in meter square, you need to have the radius and the height in meters. The height is already in meters. The radius is in centimeter. Convert that to meters. You can do it in 2 ways, children. Let me just see how I've worked. If I've done it in both the ways, I can. Just a second. Okay, yeah. So let me work the alternate method for you. Just a minute. Okay, so radius is 28 centimeters. Radius 28 centimeters. And height 4 meters. Not wrong. Yeah. 4 meters. What I just explained is this. So 28 centimeters is equal to 28 by 100 meters. Okay, so that's nothing but on simplifying 4 sevens are 28, 425 times 100. So 7 by 25 meters. A radius is 28 centimeters. We'll convert that to meters. So 28 by 100 meters. On simplifying using the tables of 4, we get 7 by 25 meters. And height is 4 meters. So the CSA of one pillar, CSA of one cylindrical pillar is equal to 2 pi RH. 2 pi RH. So 2 into 22 by 7 into R, which is 7 by 25 into H, 4 meters. 7 cancels out. So you get 44 into 4. 44 into 4, which is 176 by 25 meters squared. 2 into 22, 44. 44 into 4, 176 by 25 meters squared. This is the CSA of one pillar. So how many such pillars? 24 such pillars. So the area of all the 24 pillars, area of 24 pillars is equal to 24 into 176 by 25 meters square. Now the cost of painting is equal to area into rate. Whatever is the area into the rate. What's the area? 24 into 176 by 25 into the rate. What is it given? 8 rupees. 8 rupees. So let's continue here. Using a calculator. 24 into 176 into 8. 339,792 divided by 25. 1351.68. I have not made any careless mistake. Okay, yes. So you can handle this in two ways. So here we have both the radius and height in meters. Radius and height both in meters. So find the CSA of one pillar, 2 pi RH. So it will be in meters square because the values are in meters, areas in meters square. So area of 24 pillars will be 24 into 176 by 25. You can multiply and give the answer here. I've not done it. This is also fine. You can also leave it like this. Now the cost of painting is area into rate. So 24 into 176 by 25 into the rate, 8 rupees per meter square. So yeah, on simplifying, we get 1,351.68. So this is the total cost of whitewashing the 24 pillars. The method you see here is, there's no big different method, meaning it's not an alternate solution. The procedure is the same, just that we have radius and height in centimeter here. So how do we work it like this? So here the radius is 28 centimeters. So we have this 28 centimeters. Height is 4 meters, which is 400 centimeters. Height is 4 meters, which is 400 centimeters. See, when you substitute the values in a formula, all the variables, the values must be substituted in the same unit. You cannot substitute radius in centimeter and height in meters. So we need to come to some conclusion. Either have radius and height both in centimeter or both in meter. Anything is fine. One second, children. Yeah, thank you, children. So radius is 28 centimeters, height is 4 meters or 400 centimeters. So CSA of 24 pillars I've written straight away, 24 into 2 pi RH square units. CSA of 24 pillars, one pillar is 2 pi RH. 24 pillars will be 24 into 2 pi RH. So radius 28 centimeters, height 400 centimeters. So since we've substituted radius and height in centimeter, the answer will be in centimeter square. Now you need to convert this to meter square because the rate is given per meter square. The rate is given per meter square. So you need to convert this one to meter square. So to convert centimeter to meter, millimeter, centimeter, decimeter, meter. To convert centimeter to meter, you need to come down. So divide by 100. Centimeter, meter. To convert centimeter to meter, you need to divide by 100. So to convert centimeter square to meter square, do the same thing 2 times. Whatever you have to do it 2 times. Centimeter cube to meter cube, 3 times. To convert centimeter to meter, we need to divide by 100. So divide by 100. See, divide by 100. To convert centimeter square to meter square, do the same thing 2 times. So again divide by 100. Again divide by 100. So it will be 100 into 100. Dividing by 100 2 times is like dividing by 10,000. Dividing by 100 2 times is like dividing by 10,000 is equal to dividing by 10,000. So centimeter square to meter square, whatever you have to do. If you have to multiply by 100, do that 2 times. Divide by 100, do that 2 times. If you're converting centimeter cube to meter cube, so there'll be another 100 here. Into 100, into 100, into 100 in the denominator. Because we have to divide by 100 to convert centimeter to meter. So that gives you 168.96 meters square. So now this is in meter square. See, that's what we got. Okay, here I didn't calculate, so you cannot see that value here. You can leave it like this. What I've done here, no, you can just leave it like this. So you cannot see that answer here, area of 24 pillars. But it'll be the same. When you work this, it'll be the same as this one here, 168.96. Now the cost of painting is equal to CSA into rate. So this is the CSA into the rate is 8 rupees. And this is the total cost. So here what we need to understand is, if we have to find the cost of painting, it need not be specified that only the curved surface area has to be painted, because only the curved surface area is available to be painted. Even if you want to paint the circular top and bottom, you cannot, because they're not visible. They're stuck. So painting here is only painting the curved surface area, because only that area is available or visible to be painted. Okay. So here find the height of a cylinder. Find the height of a cylinder whose radius is given and total surface area is given. So whenever the volume CSA or TSA is given, write out that first. TSA of the cylinder is equal to 968 centimeters squared. When you're given volume CSA or TSA, write that. TSA of the cylinder is equal to 968 centimeters squared. Now what's the formula to find the TSA? 2 pi r into r plus h. 2 pi r into r plus h is equal to 968. Now 2 into pi is 22 by 7 into r is given 7 into r plus h, 7 plus h is equal to 968. Now you can cancel. 7 and 7 gets cancelled. So 2 into 22 is 44. 7 plus h is equal to 968. Now this 44 will come for division to the other side. 44 comes for division, and that's 22. So h is equal to 22 minus 7, 15. So the height of the cylinder is 15 centimeters. It's very simple. TSA is given, write that. Below TSA, write the formula to find the TSA is equal to 968. Now you can see in this equation, there are two unknowns. In this equation, there are two unknowns, R and H. But we know the value of R. So when you substitute for R, H is the only unknown. So you can easily solve that equation and find the value of H. Got this one. So here there are two there are two cuboidal boxes as shown in the given figure. See, a cube can also be called a cuboid. There are two cuboidal boxes. You'll wonder, like, the first one is a cuboid, the second one is a cube. Yeah, you can, a cube is a cuboid, but a cuboid cannot be called a cube. Every square is a rectangle, but every rectangle need not be a square. Every square is a rectangle. You can call a square a rectangle, but you cannot call a rectangle a square. A cube can be referred to as a cuboid, but a cuboid cannot be referred to as a cube. So there are two cuboidal boxes, so there's no mistake there, as shown in the given figure. Which box requires lesser amount of material to make? So material is used to build the body of the boxes. If you have to stuff something inside the box or fill the box with something. See, when do we have to find volume? When do we have to find area? Area has to do with the external part, the external surfaces. What makes the body of the, the solid? Area is an external part, what you can feel, the outside of the solid. But volume is to do with the internal portion, like you fill something into the cuboid, or if it's a cylinder, you pour something into the cylinder. So when you do something with the internal space in the solid, that's volume. If it's something to do with the external part, the surfaces, outside surfaces, then it is area. Now, which box requires lesser amount of material to make? So the material used will make the body of the box. And the body is nothing but the area, which you can feel outside. It's the area. So you need to find the total surface area of both the boxes. You need to find the total surface area of both the boxes, not the volume. You should not compare their volumes because you're not doing anything inside the box. There are only two things, volume, area. It's not volume, it's area. So find the TSA. Wherever the TSA answer is less, that would need lesser amount of material to make. So find the TSA using the respective formulae. And wherever the answer is less, that one would need lesser material to make. Okay. Yeah. Class, use the emoji, raise your hand. Shivam, you were late to join. I don't know when you joined the meeting. Aishwarya, Gayatri, Ariston, Shri. Shri also, when I started the meeting, you were not there. Saujanya, Harsha, Anantika and Yarni, are you both there?
Yes, ma'am.
Okay, good, good. Okay, I heard from both of you. Fine. All right. A suitcase with measures 80 centimeter by 48 centimeter by 24 centimeter is to be covered with tarpaulin cloth. Tarpaulin is a material, like we say canvas, tarpaulin. It's a material. Okay, so a suitcase a suitcase with measures. You can see the length, breadth, and height is to be covered with a tarpaulin cloth. So when you're covering the suitcase with tarpaulin cloth, you're going to wrap up the box externally. So you're going to, that's got to do with the area, the total surface area of the suitcase. You're not stuffing the suitcase with the tarpaulin cloth. All right, you're not stuffing the suitcase. You're not doing anything with the internal part of the suitcase. You're covering the external part of the suitcase with tarpaulin cloth. So that is area then. And since it is covering the suitcase with tarpaulin cloth, it's a total surface area. If they are covering only the curved surface area, that should be mentioned in the question. Nothing is mentioned. So it is a total surface area. Okay. The question is how many meters of tarpaulin of width 96 centimeters is required to cover 100 such suitcases? Listen very carefully. Now, you need to find the total surface area of one suitcase. because you're wrapping the suitcases with tarpaulin cloth. You're covering the suitcases with tarpaulin cloth. It's to do with the total surface area of the suitcase. So find the TSA of one suitcase, 2 of LB plus BH plus LH. Multiply that by 100 to get the area of tarpaulin required to cover 100 suitcases. 2 into LB plus BH plus LH will give you the area of tarpaulin needed to cover one suitcase. Multiply by 100, you will get the area of tarpaulin needed, the area of tarpaulin needed to cover 100 such suitcases. Please understand, when you find this, you will get the area. This one will give you the area of tarpaulin needed to cover one suitcase. When you multiply by 100, it will give you the area of tarpaulin, that material needed to cover 100 suitcases, 100 identical suitcases, 100 such suitcases. Now, we'll just assume that the answer is this one, this one, centimeter square. We'll just assume so. The total surface area of all the 100 boxes, suitcases, is 96,000 centimeters squared. So I know that I need so much of, tarpaulin. This area of tarpaulin, I understand that I need this area of tarpaulin to cover all the 100 suitcases. But if I go to the shop, I need to mention the length of tarpaulin I need. See, nowadays, we buy mostly ready-made garments. So I don't know if you've visited, any fabric store and purchased fabric, unstitched fabric. Okay. So if you were to buy fabric, the unstitched one from a store, you need to specify the length of the material you need. You need to specify. See, even if you tell him the area, the shopkeeper will calculate. But you want to be smart there, right? You don't want somebody to help you out there. You want to be clear as to what and how much you want to buy. So how will you calculate? If you tell the shopkeeper, I need this area of tarpaulin, he's going to help you. He will calculate and give you the right amount of material you need. But how will you do it yourself? You need to specify the length of the material, the length of tarpaulin. You should tell the shopkeeper, give me 10 meters of tarpaulin or give me 100 meters of tarpaulin. You'll have to specify the length, meter or centimeter, whatever. You need to specify the length, not area. So now we know that area is equal to L into B. Because how is the fabric in the shop? It's rectangular. The fabric, if you have seen, the fabric is actually wound around steel rods. Correct? Some metal rod or maybe some plastic rod or pipe. The fabric is wound around it. And the shopkeeper will spread the fabric open, and if you say 10 meters, 20 meters, he will use a meter rod. He'll have a meter rod to measure every meter. So he'll use the meter rod and he'll measure 10 meters, 20 meters, how much ever you want, and give it to you. The fabric is rectangular. The fabric is rectangular. But you will only specify the length of the fabric because the breadth of the fabric is fixed. This you and I cannot decide. The breadth of the fabric is fixed. You and I can only decide the length of the fabric we need. You cannot tell the shopkeeper, give me this length and this breadth of fabric. The breadth of the fabric is fixed. And here you see that the breadth of the tarpaulin the breadth of the tarpaulin material is 96 centimeters. It's fixed. It's fixed, 96 centimeters. It's fixed. So you have to tell the shopkeeper what length you need. So what is the area? What is the area you need? 96. Assume this much. This is the area. Now we know that. So this area should be in the rectangular fabric. This rectangular fabric must have this area. This rectangular fabric must have this area. How do you calculate the area of a rectangular fabric? L into B. L into B should give you this area. You don't know how much length to buy, but the breadth is fixed to 96 is equal to 96000. So L is equal to 96000 divided by 96. So L is equal to 1000 centimeters. So 1 meter is 100 centimeter, right? 1 meter is 100 centimeter. So this is 10 meters. 1000 centimeter meaning 1000 centimeter meaning 10 meters. So you need 10 meters of fabric. So you must tell the shopkeeper to measure 10 meters of fabric. So if you buy 10 meters of fabric, that length into this breadth will give you this area, which will be sufficient to cover all the 100 suitcases. So let's see the answer, the actual answer. So the area of tarpaulin needed to cover one suitcase, 2 of LBBH. Substitute, calculate carefully, 13,824. Area of tarpaulin needed to cover 100 such suitcases will be 100 into this one. Now, why have I equated this to L into B? Because we need this amount of this area of fabric, this area of tarpaulin. We need this area of tarpaulin, and in the market, when you buy the material, it is rectangular in shape. It will be rectangular. So this area should be in L into B. This L into B should give you this area because the fabric is rectangular. Tarpaulin is rectangular. So L into B should give you this area. L into this is L, children, not 1. L into the breadth is fixed, 96 is equal to this area. So L is equal to this one divided by 96, which is 14,400 centimeter. Convert that to meters. So 144 meters. 144 meters. So if you tell the shopkeeper that you want this length of fabric, the breadth is fixed. So length into breadth, this is the breadth that's fixed. This is the length of fabric you need into the breadth which is fixed. This will give you the area of 1382400 centimeter square, which is enough to cover all the 100 suitcases. Very simple, but very important question. Yeah. Yeah, any questions here, children? Yeah, kindly respond. Any questions? Area, why not volume?
No, ma'am.
Okay. All right. Find the side of a cube whose surface area is 600 centimeters squared. Find the side of a cube whose surface area is 600 centimeters squared. See, what we have understood is write out whatever is given first. So like surface area is given, and it's not mentioned if it is total surface area or curved surface area. When nothing is mentioned and when nothing can be assumed, it is always a total surface area. Nothing is mentioned. Surface area is it total or curved? It's just given it's a cube. So you have to take it as the total surface area and not curved surface area. So the total surface area is given to be 600 centimeters squared. So what's the formula to find the TSA? 6a squared. cube, TSA is 6a square. 6a square is equal to 600. Write what is given. Then under this, write the formula. Is equal to 600. A square is equal to 600 by 6. A square is equal to 100. A is equal to the square root of 100. A is equal to 10. So the edge or the side of the cube is 10 centimeters. Children, just give me a minute. I'll get back. Yeah, thank you, children. I'm back. Okay. So rooks are painted, rookshire or rooksir, whatever, painted the outside of the cabinet of measure 1 meter by 2 meters by 1.5 meters. He painted the outside of the cabinet. The cabinet is, you can see in the diagram there. How much surface area did she cover if she painted all except the bottom of the cabinet?
Excuse me, ma'am.
Yes.
Have you shared your screen, ma'am?
Oh. It was shared all the while, right?
No, ma'am, it's not visible for me.
No. Now it's unchecked. I don't know. Right now, yeah, no.
Yes, ma'am.
No. Till before the earlier one, I had shared the screen, right?
Yes, ma'am. This question only.
Oh, thank you. Yeah.
No, but I can still see the screen.
No. I shared it again. It was not shared.
Oh, okay.
I just shared it. Okay. Oh my God. Okay. So here the cabinet is painted all over except the bottom. Now I've shared my screen, children. I'm sure it should be visible to all of you. Gayatri?
Yes, ma'am.
Yeah. Okay. So tell me, children, what's the formula to find the area? See, the box has 6 surfaces. All the surface except the bottom. So 4 vertical faces and the top face is painted, not the bottom. So what is the area of the 4 walls or the 4 vertical surfaces or the curved surface area? CSA is painted. So that is 2H into L plus B. Then the top is painted, the top, which is L into B. The top is L into B, area of the top. L into B. This is a rectangle. L into B is the area of the top. Okay, let me ask you something. Children, tell me, what is the formula to find the area of this face? Not about this question. I'm just asking you. What is the area? What is the formula to find the area of this face? This face. Yeah.
Mom,
What is the formula? Anantika, what is the formula to find the area of this rectangular face?
L into B.
Was it Yarni?
Yes, ma'am.
Yeah, Yarni, what's your answer? L into? Anantika?
L into B.
No. I think you're saying L into B.
So L into
Okay, Anantika is not there. Lakshana?
Mom, B into H.
Very good. B into H. This is the breadth. This is the height. B into H. See, this is the length of the box. This one is the breadth of the box. And this is the height of the box. So the area of this face, will be breadth into height. So if you call this the left face, the right face also, on the right side also the same will be the area, breadth into height. What about the area of the front face? Aishwarya, what's the area of the front face? What formula will you use to find the area of the front face? Yeah, who's confident? Tell me. Front face.
Length into breadth.
Length into breadth, is it?
Yes, ma'am.
No.
Mom, is it L into H?
Correct. L into H. L into H, because for this rectangular face, this one means the length of the box, and this one, which is the breadth of the rectangle, is nothing but the height of the box. This one is the breadth of the rectangle, but what is it for the box? It's the height of the box. So it's length into height. L into H is the area of the front face. Same will be the area of the back face, L into H. For the top face, the area will be L into B, because this is the length. And this one is the breadth of the box. This one is the breadth of the box. The area of the side faces, this one and the left side and the right side. The area of the side faces will be breadth into height. This is B, breadth into height. The area of the front face and back face will be length into height. This one is the height of the box. This is the length of the box. Length into height is the area of the front face. Same will be the area of the back face, length into height. Top face, this is the length of the cuboid or the cabinet. This one is the breadth. So L into B will be the area of the top and bottom face. Okay, so here all except the bottom is to be painted. So you have to find 2H into L plus B, which is the area of 4 walls. And you should find L into B, which is the area of the bottom. I'm sorry, which is the area of the top. This is the 4 sides, CSA. This is for the top. L into B is for the top. So this is 4 faces. This is the top face. So totally 5 faces, we found the area. The 6th face, which is the bottom, we have not found because that's not painted. Okay. So Daniel is painting the walls and ceiling of a cuboidal hall. Cuboidal hall. He's painting the walls and the ceiling. Dimensions are given to you. From each can of paint, each can meaning the container, that can. From each can meaning container. From each can of paint, 100 meters square of area is painted. So if he uses a can of paint, he can paint up an area of 100 meters square. How many cans of paint will be needed to paint the room? So remember that whenever you have to find the number of cans, whenever you have to find a number, it is always area by area, or it will be volume by volume. Area by area or volume by volume will give you a number. Okay. Area by area or volume by volume. Number is equal to area by area or volume by volume. So here, from one can of paint, 100 meters square of area can be painted. So what is the area? Actually, we have to paint 2h into L plus B plus L into B. 2h into L plus B plus L into B. We have to paint the four. Okay, Daniel has to paint the 4 walls. So 2h into L plus B he has to paint. 4 walls meaning he has to paint 2h into L plus B. And he also has to paint the ceiling, which is L into B, not L plus B, L into B. Length into breadth is the area of the ceiling. Together this much he has to paint. So this area divided by 100 meters square will be the number of cans needed. Area by area. Area by area. The bigger area, the area that is to be painted. What area has to be painted? 2h into L plus B, the 4 walls and the ceiling, L into B. This much area has to be painted. This area divided by the area that can be painted using 1 can will give you the number of cans needed. Because why this formula works is because 100 cans, number of cans into 100 meters square will be equal to this area. Okay. So area to be painted is equal to 4 walls and ceiling. 4 walls formula, ceiling formula, L into B, L into B. So this is the total area to be painted. Number of cans of paint needed is equal to this area by this area. So 5 cans. You have to totally paint an area of 500 meters square. If you have 1 can, you can paint 100 meters square. If you have another can, you can paint another 100 meters square. If you have another can, you can paint another 100 meters square. Another can, another 100 meters square. Another can, another 100 meters square. So you need 5 cans. So you need 5 cans. That's what is 500 by 100. With 1 can of paint, you can paint an area of 100 meters square. But you have to paint 500 meters square. So you need 5 cans of paint. 5 containers of paint. And here, what area you have to find is whatever is painted. You should not simply use a total surface area formula. What area is painted? The 4 walls. Formula is 2h into L plus B. And the ceiling. Formula L into B. So these two you'll have to find and add to find the total area that is to be painted. I'll just come back, children, just a minute. Yeah, thank you, children. Yeah. Describe how the two figures are alike and how they are different. Which box has larger lateral surface area? Lateral surface area is curved surface area. Describe how the two figures are alike and how they are different. Which box? So that's a theory. That's a theory question. The first part, how they are alike and how they are different. The numerical part is which box has larger lateral surface area. Children, in the next class, when I ask you the formula, please, it has to rain. It meaning you must rain formula from your mouth. The class is absolutely quiet, and some of us have been, have missed a few classes due to the exams or whatever at school. So I'm not sure. So today, from the way Lakshana answered, I'm confident that she knows it well without any confusion. Others, I'm not sure. Aishwarya also could not attend a few classes. Yarni, not clear, maybe. Saujanya, I don't get to hear from you. Shivam, I'm not sure if you know. Gayatri also busy with exams at school. Shriya, I'm not sure. Harsha, I don't know. Only if you answer, can I, understand where you are and how better I should help you. You need to communicate. So when called upon, Lakshana answers. When called upon, she definitely answers and she mostly comes out with the correct answer. So that's appreciated, Lakshana. So that shows the amount of effort and interest she shows in the class and the effort she takes to remember whatever's been taught in the class. All of us can do that. Yeah, all of us can do that. It's just that you have to take that initiative to be prepared before you take up every session. Attending the class, see, this is on mensuration. If you have the formula on your fingertips, it's, you can connect with the class better. When you know the formula and when you understand what I'm, trying to share with you, you can connect better. Otherwise, it'll just be noise from my end and you'll be looking at the clock when it will strike 9:30 so that she'll end the meeting. And that's not the purpose we are here, no? Please make sure that you memorize the formula by the next class. Every time you take up a session, you should have revised the contents of the earlier session. And you must be ready to take on with newer concepts. Simply attending class after class without revising anything. Sometimes we don't even know what is happening in the class. What is she doing in the class? I don't know. I forgot, or I don't know. I really don't know. So that attitude, that interest is not going to help you. It's just a waste of time. Waste of your time. So you're all grown up. You must understand your responsibilities. And you should do all that which is needed to make the best use of the class. So for that, the basic or the simplest The basic thing is you have to revise the contents taught in the earlier class. Revise, go through that before you take up the next session. Only then you can follow. You can relate to what I'm saying. You can understand what is being conveyed by me only if you are sure about what was taught in the previous session. Now, when it comes to a chapter like this, where it is all formula based, A1, when the formula was shared with you, you should have memorized. Because we are talking in terms of the formula. We are talking, the entire thing is using the formula. And when you don't know the formula, it's not interesting for you. That's why last class, I think last class, right. I recalled all the formulae. We spent a major part of the class, major time during the last session, recalling the formula. Actually, that is meant to be done by you at home. So we could have saved that time. That all of you should have done by yourself. That's a simple task. You have it in your book. You have to practice and remember. But that I had to do it for you in the last session, which took about 1 hour. Okay, I just believe that all of you understood what I tried to convey. Let's proceed now. Yeah. Yeah, so you can see I'm not talking about the theory part here. You can understand this. Alike is because they are solids, and different. I have written a cylinder has no corners, but a cube has 8 corners. 8 corners are here. 1, 2, 3, 4, 5, 6, 7, and 8 there. 8. Not in the middle, you understand? So 8 corners. Now, which box has which box has larger lateral surface area? So lateral surface area is a curved surface area. So for cylinder, it is 2 pi RH. For cube, it is 4a square. Yeah. So you can see that the LSA of a cube is more. And here you'll have to be careful, children. This is the diameter. What is marked here is the diameter of the cylinder. So the radius will be 7 by 2. What is marked here is the diameter. You can see from this end to this end, from this end to this end is 7 meters. So that's the diameter, which is 7. So the radius will be 7 by 2. Radius is 7 by 2. 2 pi r, 7 by 2 into h. Height is 7. Radius is 7 by 2 because this is the diameter 7. A closed cylindrical tank of radius 7 meters and height 3 meters is made from a sheet of metal. How much sheet of metal is required? So it's a closed tank. It is cylindrical and it's closed. That means we'll have to find the total surface area. Because how much material is needed to make the body of the tank? How much sheet of metal? So how much material is needed to make the body of the tank? Which is nothing but the total surface area of the tank. 2 pi r into r plus h. And both radius and height, they are in meters. If supposing one is in meter, the other is in centimeter, you'll have to take care of the units. While substituting, you substitute both in centimeter or both in meter. Yeah. Okay, so this one, the lateral, one second, this one will take some time. So let me just. Okay. Let's do this one and wind up the session for today. So here, we'll come back to these two in the next class, 8 and 9. We'll do it in the next class. A company packages its milk powder in cylindrical container whose base has diameter of 14 centimeters and height 20 centimeters. Company places a label around the surface of the container. Okay. If the label is placed 2 centimeters from the top and the bottom, what is the area of the label? Okay. So the label goes around the curved surface area. It's a cylindrical container. The milk powder container is cylindrical. Now this label goes around the body, the curved surface area of the container. The label on which the description of the product is given and many other details are given, that label, it goes around the curved surface area of the cylinder. So to find the area of the label, you have to find the CSA of the cylinder. Because the label will take the shape of the cylinder. The label is stuck to the curved surface area. So the label is cylindrical. It's on the body of the cylinder. It's on the CSA of the cylinder and it's cylindrical, the label. So the radius will be, to find the area of the label. See, to find the area of the label, you're finding the curved surface area of the cylinder. Why? Because the label is stuck on the curved surface area of the cylinder. So the CSA of the cylinder will give you the area of the label, 2 pi RH. 2 pi RH will give you the answer. Radius is, diameter is 14. Diameter, this one, diameter is 14. So radius is 7. Now, talking about the height of the label is not equal to the height of the cylinder. The height of the label is not equal to the height of the cylinder. The height of the cylinder is 20 centimeters, but the height of the label is, subtract 2 meters from the top, 2 centimeters from the top, and subtract 2 centimeters from the bottom. The height of the label is only 16 centimeters. Because it's placed in such a way that there is a gap of 2 centimeters from the top and bottom. From the top and bottom, there is this gap of 2 centimeters. There is a gap of 2 centimeters from the top and bottom. The height of the cylinder is 20 centimeters. The height of the label will be 20 centimeters minus 2 from the top, minus 2 from below, from the bottom. So the height of the label is only 16 centimeters. The height of the label is 16 centimeters. The radius, there's no change. Radius of the cylinder is 7. Of the label is also 7. The radius of the cylinder and the label is 7. 14 by 2, 7. The height of the cylinder is different from the height of the label. Height of the cylinder, 20 centimeters. Height of the label, 20 minus 2, minus 2. Minus 2 from the top, minus 2 from the bottom. 16. So you have to find the area of the label. To find the area of the label, you should use the formula 2 pi RH, CSA formula, where R is 7 and H is 16. R 7 and H is 16. So that will be the area of the label. So children, on WhatsApp, I have shared the answers to exercise 9.3 and 9.4 from NCERT. 9.3 and 9.4. But I finished, I've not completed 9.3. We have two more, 8 and 9. 8 and 9 I couldn't do. Otherwise, we finished 9.3. So these two answers from 9.3, 8 and 9 and 9.4 will finish mensuration from NCERT. All right. Please complete your classwork, children. Last class also. Only Harsha, Surya, I think Lakshana. Last class, 4 of you submitted your classwork. Harsha, I remember.
Even I have submitted.
Aishwarya, Laksha. No. Aishwarya, Harsha, Shriya, and Surya. That's all. The others did not. Shivam, Saujanya, Yarni. I'm sorry, I don't know. Gayatri. Others did not. I think Gayatri and Lakshana did not take up last session because of your exams at school. Anantika is not here now, but Shivam. Please adhere to the instructions given in the class. You don't force me to be rude later then. If I'm rude, you are responsible for that. I don't want to be rude with anybody. I just want to do my duty as a teacher. I plan the class. I plan assignments, whatever. My work is only to plan and teach. Execution you have to do. You have to take up the responsibility of executing the instructions given in the class. If you don't, you're forcing me to be rude with you. So please take care. Next class, I expect all of you to come prepared with the formulae. Come prepared to the online class with the formulae on mensuration. All right, don't forget that. I'll also remind you on WhatsApp. All right, children. So that's it for today's session. Thank you so much, children. Good night. You may leave the call. Thank you, children. Yeah.